Comforts and even luxuries that were only within the reach of the wealthy a century back can now be obtained by all, but with these advantages there are some drawbacks. These have in many cases assumed national importance, and it has become the province of the engineer to provide a remedy. Osborne Reynolds. Osborne Reynolds was born in 1842 and died at the age of 70 in 1912. In the 1870s, Reynolds turned his powerful intellect to the problem of propeller cavitation. Reynolds studied the interaction of air and water, built model ships, and figured out how to make screw propulsion more efficient. But it was his publications in 1883, 1885, and 1889 concerning hydrodynamics that brought him universal recognition. Reynolds identified the fundamental dimensionless parameter that characterizes the behavior of flowing fluids, known appropriately as the Reynolds number. Wait, is that true? The concept was introduced by George Gabriel Stokes in 1851, but the Reynolds number is named after Osborne Reynolds, who popularized its use in 1883. Sir George Gabriel Stokes, born 1819 and died in 1903, was a mathematician, physicist, politician, and theologian. Thank you, Sir George Stokes, for the Reynolds number. This is called a vortex street around a cylinder. This occurs around cylinders for any fluid, cylinder size, and fluid speed, provided that there is a Reynolds number between 40 and 103. Low Reynolds numbers generally occur in laminar flow behavior. High Reynolds number occur in turbulent behavior, as shown in this picture. Need a Reynolds number? Check out this calculator at efunda.com. This calculator computes the Reynolds number given the flow characteristics asked for. It outputs the flow type. You can expect it to be laminar, transitional, or turbulent. Fall velocity. The particle Reynolds number is important in determining the fall velocity of a particle. When the particle Reynolds number indicates laminar flow, Stokes' law can be used to calculate its fall velocity. When the particle Reynolds number indicates turbulent flow, a turbulent drag law must be constructed to model the appropriate settling velocity. Reynolds number can be defined for a number of different situations where a fluid is in relative motion to a surface. These definitions generally include the fluid properties of density and viscosity, plus a velocity and a characteristic length or characteristic dimension. This dimension is a matter of convention. For example, a radius or diameter are equally valid for spheres or circles, but one is chosen by convention.